Hello, my name is David Strickland, and I'm doing a reassessment of Chapter 18. The problem I'm doing is problem 18.x.34 in the book, in the back of the chapter. I have redrawn the diagram given in the problem here, and the problem says an electron is moving horizontally to the right with a speed of 4 times 10 to the 6th meters per second. Each of the indicated locations are 5 centimeters from the electron. What is the magnetic field of the moving electron at the indicated locations? Give both magnitude and direction of the magnetic field at each location. First off, I have written the equation for calculating the magnetic field right here. Let's see. So let's start off with P1. Let's see, P1. Here I have broken down vector, the velocity vector and r hat into their x, y, and z coordinate components. But first I had to get r hat by using sine and cosine to find the x and y coordinates of r. Right here. Once I did that, I found that found the absolute value of r and divided the x and y components of r by it here, right there. To get r hat. Once it was finished, I then got the cross product of the vector of the velocity and r hat to find the one that didn't cancel out, actually. And it was right there. It came out to be 4 times 10 to the 6th, 4 times 10 to the 6th times 10, which gave me 4 times 10 to the 7th, right here. I then plugged all of that. Plug that into the equation to get this right here. Plugged it all into the equation right here, and got negative 2.56 times 10 to the negative 16th. Sorry. So because it's negative, it's actually going in the negative z direction. So it's actually going into the plane. That's why it's actually denoted with an X, because it's going into the plane, not coming out of it. For P2 and P5, there's no magnetic field in front of or directly behind a moving particle. So those are 0 with no magnitude at all. But let's move on to P6. Let's see. Now let's do P6. First, we have to calculate r hat for this point, doing it the same way as it was done for point P1, except instead of sine and cosine of 30 degrees, it's sine and cosine of 150. Because it's just 30 degrees off of the 180 degrees, not the 0 as in P1, as the P1 was. So I used sine and cosine, plugged in the 150 degrees, and got just about the same numbers, except that the x component is now negative. Obviously it would be, if you refer back to the diagram. It would be negative. Let's see. So after calculating r hat, we find that its x value is negative also. See, its components are right here. X component is negative 17.32, and y is 10, just like last time. Okay, once you get the cross product of that, it ends up being same as before, the 4 times 10 to the 4 times 10 to the 7th. Sorry, and you just plug all that back into the same equation to find the magnetic field, and it gives you the same answer. Negative 2.56 times 10 to the negative 16th. So this is also in the negative z direction, as denoted by the x going, that circle with x, noting that it's actually going into the plane. But because the problem was symmetrical, really, especially across the x-axis, which I'm going to utilize, it actually, because the problem is symmetrical about the x-axis, all that changes with flipping about the x-axis is the y value, which becomes negative. Sorry, which becomes negative, and will cancel out the negative sign already in the problem due to the charge of the electron. Because, see, once you do the cross product of it, that 10 actually right there becomes negative 10. And once this goes into the equation, it will be in negative 4 times 10 to the 7th, which will cancel out the Q charge, the negative in the charge, and make this positive 2.56. So that's why P4 as well as P3 are both coming out of the plane in the positive z direction. That has been my reassessment for Chapter 18. I hope it was informative, and I actually hope this one was right. Thank you.